before I introduce our speaker, you've heard about the Breeding Bird Atlas, which is taking place in Maryland. This is our third year, and it's the third atlas. So you may not know there's actually a federal atlas that's been started since 1966 that covers all of the United States, and that's done every year. And our own Chan Robbins had started that. He was also a colleague of ours at Patuxent Wildlife Research Center, which is now the Eastern Ecological Science Center. So Dave will present the information on the North American Breeding Bird Survey, which is the primary source of scientific population data for over 700 species. And he is also joined by his colleague, Mikey Lutmerding. Take it away.
Okay, let's see if I can get this up and working. All right. Well, good evening, everybody. I know most of you, and probably those that I do not, I hope to meet sometime soon on a field trip here or there. Thank you for having me tonight. It's a great pleasure to be here sharing time with you. And thank you, Mary, for the kind introduction. As Mary mentioned, one of my colleagues, a biologist with the BBS program named Mikey Lutmerding, is here as well. And he'll be answering questions that show up in the chat. We'll have time for questions at the end, so please feel free to wait until then if you'd like. One thing I should say here is that the Breeding Bird Survey program is a massive program. There's just so many aspects to it, and there's a lot to talk about. So I'm going to move fairly quickly here, but I can almost promise you we're going to run a little bit long. And so, you know, you can cut me off whenever and folks can drop out. I just want to try to share as much as I can with you tonight. And I think you'll find some of this interesting, or at least I hope. Well, let me first say that, you know, what a crazy time we're living in, right? And what a crazy world this is. So everybody should probably take a moment to pat yourselves on the back, you know, right now for having gotten through these past 2 years. But if you'll go on a journey with me here tonight, I'd like to transport you away from all of that, way back to a more nostalgic time in our history, more than 50 years ago, to be exact. But first, I got to give you a warning. We're going to have some graphs that are going to pop up along the way, and you shouldn't worry about it. We'll walk through it together, and if you have any questions, you can always pop those in the chat. Hopefully I do a good job of explaining them as we go. Okay, so let's go back to 1966, which was a pretty happening time. Let's see, things that were going on back then. Back then, the Camaro had just been introduced, and sales of it started in the following year. And the Arch in St. Louis had just finished and was being dedicated. The ground was broken on what would become the ill-fated World Trade Center in New York. The Sound of Music and Dr. Zhivago were just dominating the movie awards, and new TV programs were coming out that we look back on now as classics, including the Charlie Brown Halloween special and the original Adam West Batman and the original Star Trek series. And, you know, music-wise, music can always bring back a memory. That was a time when the Beach Boys had just released their hit album Pet Sounds, and Bob Dylan put out the remarkable Blonde on Blonde album. And of course, the Beatles released the Revolver album, and they were in the studio making Sgt. Pepper, which of course everyone knows. Oh, and one other thing is, let's not forget that the formerly named Washington Redskins played in the highest scoring NFL game ever, and they won. And it was a good year for the Orioles too, because they won the World Series in '66. So these are all things that let you know we are truly, truly far away from where we are today back in time. But it wasn't all sunshine and roses back then. And we've got to remember that this was revolutionary in many respects. There were Vietnam War protests going on, civil rights marches. I mean, we were in the midst of the Cold War, caught up in the space race. And we are at the beginning of what you might call the better living through chemistry revolution. And part of that was the incredible promise of these new organochlorine pesticides like DDT and heptachlor and dieldrin. But as you know, we all know today, these persist in the environment and they have a tendency to continue poisoning birds long after they've been applied. So as campaigns in the countryside that targeted spruce budworms and agricultural pests were expanded to include urban mosquitoes and Dutch elm disease, it really wasn't long until residential areas and college campuses were starting to see scores of dead and dying birds. Well, that prompted a Midwesterner to write a letter to the then Fish and Wildlife Service biologist named Chan Robbins. And the person was asking if American robins were in decline across the country. Chan really lamented that no one could be sure because there were no rigorous monitoring programs for songbirds at such ambitious scales. I mean, you got to remember too, there were really no non-game biologists back then. That was only in '66. But, you know, this all sat uneasy for Chan, and together with the evolving story of the effects of DDT on birds of prey, which you all are familiar with from Silent Spring and subsequent publications, Chan became set on the idea of building a continental monitoring program. He thought it was badly needed and very timely. So the first question he asked himself is, well, what aspect of bird life should we be monitoring? And there are really a lot of aspects of bird life that you can monitor. So for instance, spatial distribution or geographic range. And that's what we're doing with the Breeding Bird Atlas now. That's specifically what that program measures. There's occurrence phenology. And, you know, we had seen this in a last presentation about butterflies. So we talk a lot about when certain species come out of diapause and when they're flying about. Well, the same thing is true with birds, of course. We know Cape May warblers arrive at a certain time and they depart at a certain time, and then they come back through at another time and depart at another time. So there's occurrence phenology that you can measure to see whether their seasonal abundance is changing. There's life history phenology, like when do they breed? When do they molt? These are very important things that sort of bookend the life of many birds that are in our area. There's breeding productivity. How many young do they have? There's survivorship. How long do they live? And there's population size. It's that last one that Chan set his sights on for his new project. So, you know, how do you go about measuring a whole population? Well, the truth is that's just rarely ever possible. And the only times it is if you have, say, an island population of seabirds or a situation where the whole population congregates for breeding or for some other purpose during the year. So you can count all the individuals at one time. But as you all know, even then, not every living individual of a population breeds every year. Some birds spend 4 years preparing for their adult life and breeding. And of course, birds have wings and they make good use of them. And when they're not flying, they're often doing things that make them not detectable to us. So this idea of detectability, it's an interesting one in the realm of birding. On the one hand, most of us birders, we feel really confident that our bird counts of, say, cardinals include all the cardinals that are at a place during the time that we conducted our count. And likewise, the converse is true also. So if we don't see, for example, the 2 species that I've shown here, then we're inclined to think that they were absent. By the way, here's a fun quiz for you. Can you identify these 2 birds? Don't feel bad if you can't. Because the one on the left, it's a small flycatcher, as you can see by its very vertical posture or upright posture. And it's in the genus Epidnax, which as collectively are pretty notoriously difficult to identify. And the one that's on the right is a Lincoln sparrow, which is very skulky, even by sparrow standards. So, here's a question for you. How common would you say these birds are in Howard County or Montgomery County or wherever you emanate from? You're probably saying to yourself, well, that's rare. But bird banding data show these aren't as rare as you might think they are. And that's because bird banders, by way of their nets, are better at detecting these 2 species than most of us birders are. But here's a cool fact, you can change that. You can close the gap between you and the bird bander simply by changing the way that you personally try to detect these birds. So let me show you what I mean. Both of these birds, they're hard to see and they don't sing much when they're passing through our area. But they do give call notes frequently. And if you're tuned into that, you'll start finding them, even when the banders don't. So here's an example. This bird on the left here is the alder flycatcher, and the alder flycatcher, even though it's not singing a lot of the time, it is constantly making a pip note. And that pip note is easy to pick up. It sounds a little bit like a downy woodpecker. So if you're birding in late May and early June, a time when it's starting to get hot, and many people have already hung up their binoculars in their search for migrants, if you're birding at that time and you hear that pip note, you track it down, you're going to find an alder flycatcher, and you'd be surprised how many of them are moving through and calling. Here's another one, this Lincoln sparrow. You know, if you're out in October, that's prior to when the fox sparrows are coming down, and the chip note of a Lincoln sparrow is just as unique as a fox sparrow. It's not quite as harsh, but it's that smacking sound, and they like to give it in the morning. They're extremely vocal in the morning, and they're often sitting on top of bushes sunning themselves in first light, and here's what they sound like.
I'm actually not hearing the sounds, so I don't know.
Oh, I'm sorry, is anybody else not hearing them?
No, I'm not hearing them either.
No.
Oh, goodness. Okay. Well, I'm sorry about that, folks. But you could look those things up. The chip note of the Lincoln sparrow is in many field guides, and also the pip note of the alder flycatcher is available too. So what I'm talking about here is changing your probability of detecting these birds. Okay, so the take home from that is that we can only count what we detect, and our detection isn't perfect, so our counts are not complete. This is something Chan knew well, and he knew bird counters would be missing birds, but he also knew that not all hope was lost. So let's build a graph here to see why. And we only have one axis here, so this is pretty straightforward. So let me see if I can use a laser pointer tool here. Okay, can you see this red dot? I'm going to take that as a yes.
Yes.
Great, thank you. So right here is absolute abundance, and you would only know that if you're an omniscient, because there's a lot of birds out in the world and we can't see them all. So this absolute abundance is only known by some being that's not us. And then there's your count, which is less than that. So here's the number of birds on the left-hand side, and this will be the same all night, more at the top, fewer at the bottom. And so your count is going to be fewer than absolute abundance. Now, remember that the person who wrote to Chan hadn't asked how many American robins there were in the world. They asked whether the robin population was declining. And a decline is a change that happens over time. So to measure that kind of change, you need to perform counts across time. So let's throw a new axis onto our graph here. And that's going to be down here on the left. I mean, down here at the bottom. And on the left-hand side, it's always going to be some earlier time, and on the right-hand side, some later time. So here, let's plunk down 2 more points. So this is what happened in the real population, which only the omniscient knows. And then here is what our count was. And so the difference between these two things, that's trend. So what you're seeing here is that even though your counts aren't complete when you go out, they can still track the population trend just the same. And that's what an index to abundance is. Index means to point to. So it's not exactly the total abundance, but it's something that correlates with it. But it's not that simple, because for a count to faithfully track the real population trend, you've got to control for 2 types of error. And the first type is called normal error. And that's the kind of error you get when you have too few samples. And you can see this kind of thing when you flip a coin to find out if you have equal chances of getting heads or tails. If you only do it a few times, well, just by random chance, you're going to get more of one than the other. But if you do it hundreds of times, your sample size will be large enough that it'll bear out that indeed you're equally likely to get heads and tails. So Chan's solution to this problem was to create a survey, a bird survey that he knew Americans would be inclined to participate in, so he could get the sample size way up there. And he recognized that, you know, compared to Europeans, we Americans, we're really wed to our cars. So he decided that this new survey that he was creating was going to use the extensive North American road network that we have. But even after you overcome this normal error by having lots of people participating, you face another more complicated type of error, and that's called bias error. So bias error is easiest to understand if you think about a hypothetical example. So let's imagine how we might count the number of people in a city like Washington, D.C. And let's say you have a small staff of 4, and you can't afford to send forms to every household in DC on a periodic basis, kind of the way that the US Census does. So you might decide that your best strategy is to station your staff at 4 different corners in the city, and they'll count the number of people in each vehicle that passes by. And if they perform that same count in the exact same places for the same amount of time at exactly the same time of day, but just a year later, then the results should reflect whether there was a real change in the overall number of people in the city between that first year's counts and the second year's. But your staff performs their counts at 8 a.m. the first year, but 11 a.m. the next year. What do you do then? Or what if they counted for 2 hours in the first year, but 3 hours in the next year? I'm sure you get the point here. How you count is every bit as important as what it is you're counting. And so even if the number of people in the city hadn't really changed at all, just those subtle changes in the way the counts were performed is enough to dramatically change the count results between the years. So in other words, if the chances of detecting something changes, then of course your count results will change. And that change won't have anything to do with the actual population size. So it won't be a faithful representation of real population change. So let's get out of the hypothetical here and get back to the birds. Instead of doing a count of people in cars from a street corner, what Chan was planning to do is to do what's called point counts. And so you see a point count in this slide. Here you have a person who has a pad of paper and they're writing down things that they're hearing and seeing. And essentially, if you were in a spacecraft up above this person and you had tracking device on all the birds, what you would see is a Carolina chickadee came in and flew across and he counted it. And there was an American crow calling and a goldfinch flew across and 3 blue jays flew across, followed by a red-tailed hawk, or maybe it was the other way around. But either way, he counted them all. So using this point count system, Chan wanted to build into it as many controls for that error bias that I just mentioned as he could. So here's a quick list of the big error biases that he was trying to control for. And let's spin through these real quick in a little more detail. So your counts will not closely track the population change unless you select your sampling sites in an unbiased way. Unless you sample sites that remain in the same place between years, and everyone has to put in the same effort, and every counter has to meet the same minimum skill level, and you have to avoid any conditions that interfere with counting. So again, here's that in a little more detail. So free choice is something we birders are all about because we're drawn to places that have nice habitat and they're usually protected and they're geographically convenient and we have easy access to them. After all, how many people want to count in areas that are increasingly being developed? But that's where the biggest changes are usually happening. So if you have free choice, you usually are going to be counting an area that's not really representational of the landscape as a whole. There's also the issue of duration. As I had mentioned in the city, it stands to reason that if you have more time to count birds, your count results will show more birds. And when we think about how daily traffic patterns in that city would have been affected or would have affected the counts, well, the same goes for activity level in birds. So if you look here, at the bottom is no singing and at the top is lots of singing. And here's sunrise and then here's lunchtime. And so what it shows is that in the morning, birds are really singing. But boy, by the time you hit 8 or 9 o'clock, they start dropping off. And then by the time you're in the late afternoon, good luck. You're not going to find that many. Your detection probability has gone way down. So Chan's idea was that each stop should be sampled at the same time each year, as close as possible anyway to the time it had been sampled in previous years. Okay, so this is where the city analogy starts to fall apart on us. Birds in our part of the world, they tend to commence breeding at the same time, and that's called synchrony. So you don't go out in March and find an American redstart. In fact, you go out at late April and early May, and pretty much they all the males show up at about the same time. And there's a lot of selective pressures on them to ensure that they do this. And then they're singing and pretty detectable throughout the height of the breeding season. And like most birds, by the time they start molting, they become quiet and then they pass through again. And so, you know, if you're doing bird counts, you want to try to make sure that all of your sampling is done when they're most detectable. And that's the height of the breeding season for most birds here. And then, of course, we're all familiar with this. Counts are easily biased depending on people's ability. You know, it's pretty easy to count cars in our city example, but we all wish that were the case with birds. And we all have a learning curve and we're all on it. We all help each other get as high as we possibly can. But Chan recognized that there's a trade-off there. You want to include as many people as possible, but at the same time, if they're below a certain skill level, their progression through the learning curve is going to be captured in the data that they collect. And so you're going to find increases in birds simply because they're getting better every year at detecting birds. So Chan's idea was to get people into the survey when they're already on the asymptote. Now, that works on both ends though, because hearing loss, man, it's happening to all of us. It's happening to us right now on this phone call. I'm sorry I'm taking up your time. You just lost some of your hearing as we all slowly progress on the hearing curve. But it's what happens. It's part of being a human. And these two species here turn out to be an excellent litmus for how we're progressing on the road to senescence. Let me ask you, can you hear the high-pitched calls of golden crowned kinglets and cedar waxwings, these two birds here? Oh, here's something cool about this. Sorry, I'm going to go on a ton of tangents, but I can't help myself. Does anybody notice anything unusual about this cedar waxwing? I'll pull your attention to it. Cedar waxwings have a tip at the end of their tail that's usually yellow. Yeah. The band at the end of this one's tail would normally be yellow, but because this bird ate berries from an exotic honeysuckle that fruits in June and July when the nestlings are growing in their tail feathers, the tip of this bird's tail came in orange instead of yellow. And the culprit is a red pigment in the berries called rhodozanthin. And adults don't normally eat rhodozanthin at the time that they're molting their tail feathers because the berries are not fruiting at that time when they molt later in the year. So all this to say that this orange tail is a pretty good indicator of age for this bird. Here's just proof positive of what I was telling you. So if you're 90 years old, chances are you do not hear golden crowned kinglets and cedar waxwings because they're in the like 6 to 7 kilohertz range. So they're about up here. And so what you're seeing here is like, this is your ability to hear the birds on the left-hand side. And if you're up at the top here in the green, you know, you're doing really well. That means you're a spring chicken and you're hearing a lot of stuff. You're about 20 years old or less. But if you're down here, you're not hearing much at all. And so by the time you're 90 years old, you're really not hearing much in the 6 to 7 kilohertz range. And that happens to all of us. It's just the senescence of life, and we start dropping off in that range. Sorry, I don't mean to bum you out. Just letting you know we're all there. Okay, so as I mentioned too, weather conditions really affect our abilities to detect birds. And here's a couple of them that are really bad. As we all know, wind is terrible for birds, or at least for our ability to detect them. You know, birds don't like visually noisy environments. They have to constantly be vigilant for things like Cooper's hawks or sharp-shinned hawks that may be coming in to prey on them, or cats or whatever. And when there's a lot of visual noise because leaves are moving, it's very stressful for birds, and they tend to do things that make them less detectable, like, you know, acting like towhees, hiding under bushes and so forth. And fog and smoke and rain, they're also really challenging conditions too. Okay, so here is what Chan was setting out to make when he created his new survey, which he called the North American Breeding Bird Survey, or BBS for short. So he wanted to have a very clear goal for the survey. And this is important, and I'll tell you that, especially in today's day and age, because people are not always careful about exactly what programs are supposed to do. But it's pretty clear for the BBS. We have a mission statement, and the essence of it is that we measure trends at very large scales. So in other words, this survey does not measure, say, the number of black rails in the Elliott Island marshes. Its design is optimized to sample the bird life of an entire continent. For bird count data to be used in the kind of governmental decision-making that we all imagine that bird count should be in, like, you know, we all look at each other and we say, man, there's more than enough data for that. But the key is that data have to be able to hold up to scientific scrutiny and in matters of litigation as well. We don't often think about that because we all tend to think alike in the bird world. But if you are a developer who really doesn't know what a black-capped chickadee is, or Carolina chickadee, or some other bird that we have a great deal of love for, then for them, there's no love lost when they propose to put in a development or have some other serious financial stake into something they want to put in, and they kind of think we're a little bit lunatic for that. So you need to have something you can put on the table that's not partisan information. It's not information that anybody owns. It's just good, sound, scientific information. And that's what the BBS really strives to do. The BBS uses a sampling design that's built on solid statistical precedents, and it really has a very sound construct behind it. So let's talk about that real quick. The sampling route, or excuse me, the sampling unit in the BBS is called the route. And each route is a length of roadway. It's about 25 miles long. And they're on secondary and tertiary roadways. We don't want people to get run over, and they tend to be less congested, of course, and there's less noise along them and less development. And the observer during a survey makes 50 stops along that route at predetermined points and conducts a point count at each one of them. And each of those points is about a half mile apart. So BBS routes, as I mentioned, we're trying to avoid that bias of habitat selection. So BBS routes sample habitats in proportion to their occurrence on the landscape. So observers don't have the freedom to choose where their sampling locations are. And that means that, you know, things like steep hillsides, marshes, et cetera, all these things that are avoided in roadway construction, those are kind of rare habitats on the landscape to begin with, and they're not sampled very well by the BBS. They need very special surveys. For instance, for cerulean warblers, if you were trying to get a very good survey of cerulean warblers, they're almost always on the east-facing side of slopes, and there are not roads typically on those, which if you imagine like the Susquehanna River, there's not a lot of roadways in the areas where the cerulean warblers there, or the Catoctons is another great example here in Maryland. The routes are distributed across the states in a longitudinal, using lattice-long blocks, which are basically blocks of 1 degree latitude and longitude, similar to how the atlas is formulated. And they're distributed evenly to prevent clustering. And in the image here, you can see, I think that's Wyoming there, and the distribution of routes there. and how the routes are pretty evenly distributed across the state. And also the top is just to show that's how we create these things. We flip coins and we do random stuff. So it's not as if these routes are selected intentionally in a particular area other than the stratification I mentioned. So these routes, they're also nested in various other strata too, because each route has a designation for country or bird conservation region or the physiographic strata in Maryland. That means like coastal plain or Piedmont or Appalachian Plateau. And they're also stratified by political boundaries too, like state. So that means that although the survey is designed to provide a continent-wide picture of population change, its results can also be pulled into smaller ecologically similar or politically similar units for comparative nested analyses. So all BBS counting is performed the same way, and it's a pretty simple method. Samples occur only once annually. So each route is sampled only once in a year. And it happens within a pre-described period during the height of the breeding season, which is usually June and July throughout the most of the US and Canada. And it starts at a predetermined start time, which is a half an hour before local sunrise. And any of you who are Atlas folks, and you saw the stuff that Sue and I put together recently talking about owling and about nocturnal hours, you'll see in there that I mentioned twilight hours. And that's what we're really capturing here is a half an hour before sunrise is when birds are waking up. And all surveys are conducted under favorable weather conditions. Again, these address the biases that I had mentioned before. Only one observer, and only one observer, the assigned observer for that route, can detect birds during the counts. And what they're doing is during their point counts, and they're doing 50 of them along that route, they're counting all birds that they've heard or seen during a 3-minute period of time. And they're not permitted to count before that 3-minute period or after that 3-minute period. And they're counting everything they encounter within a quarter mile of that point. And if you remember that the points are about a half mile apart, the idea there is that the counting radius around each point does not overlap. So we have highly skilled observers by design. The skill standards for conducting a BBS survey are extremely high, and observers must be able to identify all locally breeding species by sound and also by sight, of course. Our observer pool is made up of folks who are really highly experienced. About 90% of them have been birding or pursuing bird-related interests for more than a decade. And it's a lot more than that for most of the folks. And most of them spend more than an hour a week birding, and about 72% of them, so the overwhelming majority, spend more than 5 hours a week birding. About half of our participants work in either the natural resources management area or some field related to it, maybe science or government or something like that. And that's a little bit misleading because it's a chicken and egg kind of thing. We all know folks who are young and are trying to start out their career in natural history. Well, those folks are looking for jobs that allow them to get paid for the things that they like. So it's not surprising that many BBS observers are also working in the field. So today, this is the extent of the survey. We've got about 4,500 survey routes, and they're all across the United States and Canada. And the survey is administered jointly by the USGS, by Environment Canada and Conabio. And those latter two are basically the equivalent of the Fish and Wildlife Service in Canada and in Mexico, respectively. Our office here in the United States handles the overwhelming majority of the sampling, which is, I think, maybe 80% of it or something like that. And we maintain all of the infrastructure, which includes password protected websites with over 900 pages, a massive database with millions of records in it, all kinds of stuff like that. But with all that said, and despite the fact that the BBS program samples more than 700 species, and we provide 50-year trends and more for about 400 of those, the program comes in at a cost of around $1,000 per species per year. I mean, it's just unheard of. And for relative context, all you need to do is just consider how much is spent on monitoring threatened and endangered species that a more local level, like red cockaded woodpecker or something like that. So the survey is really pretty well known throughout the world as being very efficient, which I'll mention in a minute. But at any rate, that's where we are now. But the road to getting here was actually not that hard of a road. I mean, Jan did such an amazing job of rolling out the survey. I mean, he spent about 10 or 15 years really working out the survey before he started it, which is something I'll mention here just as a side note, just because I hear so many times today that we need to do things. We need to do it now. We need to do it really fast. But the thing about that is that, you know, Roger Tory Peterson's field guide or the North American Breeding Bird Survey, these things have lasting permanence, not because they were done quickly, but because of the amount of thought and the amount of care that was put into really formulating them to make sure that they were something lasting. And that's something that's difficult to balance nowadays, but it's something I think we all should think about, especially because the decades ahead are going to be challenging ones for us, and we really do want to make lasting change. So the BBS began in earnest in 1965 as a pilot program, and there were 50 routes in Maryland and Delaware at that time. And then in 1966, the program was launched in all states east of the Mississippi. So there were about 600 routes. And then in 67, it spread to all states east of the Rockies. And then by 68, it was coast to coast with about a little over 1,800 routes. And then later editions have included the Yukon, Newfoundland, Labrador, and most recently, well, I guess Northwest Territories was 87, and then Nunavut was even more recent than that. So now the survey is truly a continental survey. What you see here is, again, time on the bottom here. So this was 1966 when it started, and all the way over here is pretty close to where we are now. And then here's 0, and then here's 4,000. And this works for both the number of routes that we get surveyed per year. So we're between 3,000 and 3,500 routes sampled per year. And the number of observers has steadily increased over time as well. And there's been about 8,000 people that have participated in the survey in the last 4 decades. About 75% of those over the long term have been on a volunteer basis. So all of that amounts to about 30,000 hours per year, which is the equivalent of like 15 federal full-time equivalents. So, I mean, it's just astounding what observers do and the quality of science that they have provided. The first published analysis of the BBS occurred in 1986. So that's like right about here. And then that was a 15-year survey. And then this groundbreaking paper came out in 1989. Jan Robbins and I believe Sam Drogan and a couple other folks were on that. And they published it in the Proceedings in the National Academy of Science, which is a very prestigious journal. And it was basically documenting the decline of migratory birds. So that was like right about here. And then this led to the formation of Partners in Flight, which was right about here. And then, you know, there was a lot of recruitment via that. And then we've kind of steadily grown over time to the point that we're at now. And, you know, growth is just an indicator of how much effort you put into pulling people in. And that effort should really be commensurate to need. So the fact that we've plateaued out there doesn't mean there's not capacity for more growth. What it means is that there's not need for it. Our sampling has been sufficient so far, but we are talking about increasing that to refine the scale of the survey. So anyway, I just mentioned that to help you interpret what that asymptote means, or that plane. So in the 56 years since the survey started, it's become recognized worldwide as a model for efficient wildlife monitoring. And it's recognized as one of the most scientifically rigorous citizen science programs that has ever been created. And what you see here is that it really plays a part in all stages of the conservation and management and planning cycle that the federal government and that stakeholders do. And it's about 150,000 point counts that are conducted annually as part of these route surveys. And the surveys amassed about, oh, I don't know, 95 million bird sightings in our database. And we provide a continent-wide picture of the health of bird populations of, as I mentioned, you know, over 600 species, close to 700. And Let me move around along here. I don't want to lose too much time. The survey on the back. More recently, though, I will say that it was the foundational data set that was used in the 3 billion birds lost paper, which most people are familiar with, that came out in Science a few years ago. BBS provided 82% of the information that was used there. And you can see in this little graph here, 0 is no publications. And of course, there were no publications prior to 66 using BBS data, and 400 is up here. So today, we're pretty close to the 400 publications that come out per year that substantively use BBS data. I'm not saying, recognize BBS trends and say, Eurasian collared dove has increased by such and such percent. This means they use the data set to actually perform the fundamental analyses that answered some research question. So substantive use. And the BBS is going to continue playing a role in supporting the response to that 3 billion birds paper, because we're going to continue being a foundational source of information for North American bird population trends. And we're working to enhance the program's products and our coverage so that the survey will fill important roles in the decades to come as well. So I know that I'm running a little long on time here, but I'm going to try to run through a few birds here if you stay with me. And Mary, please cut me off.
You're fine. You're fine.
So Maryland has 58 active BBS routes in it, and they're distributed as you see here. And our program has been blessed with an extremely talented and dedicated base of volunteers here in our state. And, I got to do it because he's here. He's gonna feel uncomfortable. I hope he's got his camera on so we can all see him squirming. But I'd be remiss if I didn't take the opportunity to make special mention of David Holmes. David started as a BBS volunteer in '68, and so he just barely missed the inaugural year by a couple of field seasons. And his record of participation in the BBS, it really typifies the spirit of service that has become a hallmark of our observer flock. Nearly 450 surveys run. Wow. I mean, that's about 6 hours for each survey. You have to take time off of work. You got to get up early before sunrise. He's driving all over the place, or he was driving all over the place to do these surveys. And then he would take time to carefully curate his data and enter it into our online data systems. And at times he was conducting as many as 15 surveys per season. I mean, that's really difficult to find in June, 15 days when the weather is really nice and amenable to it. So observers like David, they're recruited today in much the same way as when the survey began. We have a network of committed state coordinators who are expert birders in their own right. And these folks keep a finger on the pulse of their state's birding community to find those who have the skill and the commitment to contribute in the way that so many before of them had, which David really typifies. So our hats are off to you, David, and also to Lynn Davidson, Hal Waranger. I mean, just the list goes on and on of just so many great people here in the state. Many of you, I'm sure, have participated in the survey as well. Okay, so there you go. I ran through all that stuff. I hope I didn't leave you discombobulated, but let's get to some birds, right? So the quintessential BBS product is population trends. So why don't we take a look at some here? I do have to say one other thing here. I could devote an entire slide talk to thanking John Sauer, who essentially created the modern BBS trend analysis paradigm. It's just impossible to sum up what he has done over the years, but all of the stuff that you see here and analytical results and the fact that BBS is so well used is really thanks to him, but I'll leave all that praise for another day. So what you're seeing here is a graph of Carolina wren trends in Maryland. So again, the axis over here, this tall one, is a low count at the bottom and a tall one at the top. And if you're really interested in the numbers, it just basically means the average number of birds that people were picking up on their routes. Here's 1966, and then here's much later than that. Now, I didn't make this graph so long as to include today for a very specific reason, because the longer you make the graph, it's just harder to see the details in here. And anyway, what I really wanted to say here is that many people may not know this, but Carolina wren is a relatively recent arrival to the North American landscape. And it dispersed northward out of the tropics on the order of just, tens of thousands of years or thousands of years, even in some cases. So it's really a warm weather bird at the heart of things. It loves climate change, let's put it that way. But BBS trend results and our data set tell the story about this bird being a tropical bird, and you can see that here. So what you're seeing with these ups and downs is the ghost of winters past. And each of these that you see a green arrow here was a considerable winter event. So the tidal Potomac froze solid in 1977, and you can see what happened to Carolina wrens and the blizzard of snow and ice in 93 and 94, blizzard of 96, blizzard of 2000, President's Day snowstorm in 2003. Well, remember, there's more bird feeders out there now than there were before, and there are a lot more houses out there than there were before. And that means there's a lot more spider nests or spider overwintering shelters that these birds are experts at picking out. So trends still drop now when we have these severe winter losses, but they recover, or severe winter events, but they recover much more quickly. And essentially that was what was happening back here in like 77 is all Carolina wrens in our area were pretty much killed off. And then individuals had to slowly repopulate the state pair by pair because these things are, resident. So it's just pair by pair, youngsters expanding northward all through this period here, just to ramp up here. Trends can be viewed in many different ways. And here we see how a species is fared over its entire US and Canadian distribution. So this species here is the loggerhead shrike, which is often called the butcherbird. And it's a most unusual songbird. And it has earned that gruesome name because it impales its prey on thorns, and that aids the bird in dismembering it. Because remember, raptorial birds are called raptorial birds because they have great feet that allow them to hold down prey and manipulate it as they pull it apart. Well, no such luck for a songbird. Songbird leg morphology is very unique and allows the bird to perch via some tendons when it puts pressure on the leg. That's why they're often called perching birds as well as songbirds or passerines. At any rate, it's a real challenge for these birds to hold down prey, so they impale their prey onto thorns or barbed wire fences. So what you see in this map here are the red areas are where the species has declined, and the blue areas are where the species has increased. And you can see it's not really good news for this species over most of its range. And these birds that are up here in Ontario, well, probably at least half of the people on this call or in this meeting remember when you used to go to Prime Hook or places in Delaware to get your loggerhead shrike during the winter time. And most of these birds were believed to have been coming from this population up here. And there's been a lot of restoration efforts now up in the Northeast to try to bring loggerhead shrike back. And as you probably know, there are still birds that breed in the Ridge and Valley province and on the Western Piedmont, all the way down to, like, say, Culpeper, Virginia. And every now and then one will show up in Maryland. But really, there's a lot of humans on the planet now, a lot more than there used to be. And these areas of growth here that you see, these are usually related to some weird phenomena, which we don't have enough time to talk about today, but it's not enough to really sustain an entire population coming back. So this is a species of real concern. But BBS tell the story about all manner of factors that affect birds. And as many of you will recall, West Nile virus was of great concern in the early 2000s, and it moved into our area in 2001. And here, let me show you, you can see what happened to the American crow population shortly after that. So here's 2001 when West Nile virus really came, and then boom, look at that drop. I mean, it was like, here we're at an average of 60 birds per route, and now you're down to 30 birds per route. I mean, that's half as many birds per route in just a few years. But this is not a bad news story. It's a good news story because look how quickly they started to recover thereafter. And of course, the time series goes on off of the graph here, and they are have since recovered quite a bit. I've often teased this, and I led a field trip a few months back and teased some folks about telling American crows and fish crows apart. And I mentioned to them that you can do it via the plumage. And I'll just point out here real quick, just because I see a couple of those people that were on that field trip. Well, here you go. The answer is American crow is the one with the scaly plumage. The edges of the feathers have a bit of a scale to it. That is not the case for fish crows, so they never have that scaly appearance. Anyway, just an anecdote. So following up on that, you can see through the BBS trends, not only that birds declined in Maryland, which again, here's that drop that I showed you when West Nile virus came in, but if you follow it westward here, you'll see, boom, the drop is happening later in time and later in time until eventually West Nile virus reached Oregon. So what you're seeing is West Nile virus is moving westward. Well, how do we know that? Well, we don't have great epidemiological information for this. So birds are a wonderful indicator, and the BBS has been used in a lot of epidemiological research to serve as proxies for movement of the virus. So here again, you see the scaling nature of American crow. Sorry, I can't resist. Okay, so the BBS is also an incredibly useful tool for measuring the success of our management efforts. So we usually think of this in terms of like increasing productivity, but this example here, exotic mute swans show you that sometimes declines actually mean success. And the Maryland DNR was very aggressive about dealing with this exotic species because it was causing a lot of problems. They feed on resources that migratory swans use, and they feed on it all year long. And so they're removing tubers and disturbing vegetation all year long in a way that would have affected or likely affected waterfowl populations that come here in the wintertime. So we can sum up trends sometimes with a handy dandy number. And here it's 2%, 2.7 increase per year. And if you've ever done any kind of like compounding interest, and you know compounding interest probably because if you're not an accountant or a mathematician, you just pound yourself in the leg every time you go to see your financial consultant, and then they're like, why didn't you invest when you were young? So word to the wise young people, put your money away. Compounding interest can work for you. Well, that's kind of how these numbers mean. It may be a 2.7% increase per year, but it compounds over time. And you can see here that these numbers have to be taken in perspective because clearly this is not just a solid increase through time of 2%, 2.7% per year. So that brings me to the next point, that context is really important when you're thinking about trends. So few cases illustrate this more so than does chestnut-sided warbler in my mind, which you see illustrated here. And again, the trend over time has been about a negative 0.81% decrease per year in the Northeast. So that's clearly pretty close to 1% per year. And you can see how that manifests in a line over time. So even though the number looks small, it has a big effect when compounded over time. So, you know, when we see stuff like this, it begs all of us to greet it with great concern. We're seeing a decline, but it has to be taken into account how the American landscape recovered from the Industrial Revolution that really laid bare our forests in the 1800s. So by the 1900s, there was more early successional forest than generations ever before had seen. And not surprisingly, given how reliant chestnut-sided warblers are on that early successional habitat, they were far more abundant. In fact, they were abundant at levels that earlier ornithologists could have only dreamed about and would have just found absolutely astounding. Case in point, John James Audubon saw 3 living, or 5, I think it was, living chestnut-sided warblers in his lifetime. But it might as well have been 1 because they were all on the same morning of May of 1808 in Potts Grove, Pennsylvania. So that's pretty astounding in my mind. So I want to break for questions here. But before I do, I want to say a few more bird things. So many birds are in serious decline, not all of them, but even in the cases where serious declines are occurring, you still have to be really careful about how you interpret this stuff. And this is a great example. So here in the upper right is Kentucky warbler. And Kentucky warbler, that bird requires very special habitat, a lot of understory. We've had deer. Well, first of all songbirds require habitat that is free from predators and nest parasites. And especially most of our wood warblers are very susceptible to predators because many of them nest on the ground or near the ground, like Kentucky warblers and ovenbirds, and also nest parasites like ovenbirds, like brown-headed cowbirds hit these birds very hard and can make their reproductive outputs very low. So as habitat fragmentation has occurred, and of course the wholesale loss of habitat. I mean, Howard County, think back in the 80s of what Howard County looked like, or even before then. You just can't have that much loss and not impact birds just simply because the land area is gone. So you see that happening in things like Kentucky warblers. And Kentucky warblers are getting hit by the 1-2 punch too, because when deer come in, they deplete the understory. And so not surprisingly, Kentucky warblers, which are shown in red in this graph, have declined by about almost 3% per year since the survey first began. That may not sound like much, but all of you birders who've been birding for a while, you know, these are hard to find now. Now, the thing is, some of the areas where they should be, they're not, and that's the deer thing. But check out ovenbird. It looks like it's increasing, and it is, according to the trend information. But the thing you have to remember here is they've suffered the same wide-scale habitat loss that Kentucky warblers have in terms of just being more humans on the landscape and fewer forests. So like, why is their trend not showing the way that we would expect it to? Why is it not traveling with Kentucky warbler? Well, remember, they are declining. But what is also happening is that deer are converting whatever is left over that might have been good for Kentucky warblers into perfect ovenbird habitat. Because unlike Kentucky warblers, which eschew open understories, ovenbirds absolutely love it. And so that's why you have to be very careful about considering trends and keeping it in context. So I promised I would stop. One last thing here. Here is what's happening with most of the North American bird life right now. And what you're seeing here is this is millions of birds right here. This is from the science paper that Ken Rosenberg and John Sauer and others have done using BBS data. And here's time. And it's not good for most birds. They're declining. The birds that are doing well are like water birds, because we are very efficient at mobilizing money for conservation of game birds and water birds. And they all have a similar suite, at least the water birds do. So that's a conservation success story there. And the losses that you're seeing here of many of these other birds, and these colors, by the way, correspond to habitat types over here, birds that use certain habitat types. So the biggest decline that you're seeing here is in grassland birds. And we all know that first and foremost. But remember, some of those declines in some areas like the East are because there wasn't traditionally Eastern birds in the East over much of the area that we find them in now. And then also boreal forest birds are in various serious decline, and we don't fully understand that, as you all know from not seeing rusty blackbirds and other birds that have declined in recent decades. And then, of course, some of these other birds like eastern forest birds, they may not be declining as much as some of the other birds, but they're still declining quite a bit. It's just overscored by a lot of these other very serious declines. But I'm going to end on this, I promise. It's not all bad news. A bunch of birds are increasing in Maryland. Bald eagles are just going through the roof, as you can imagine. 7.3% increase per year. That is mind-blowing. Here's another one, common ravens. Boom. What happened to common ravens? On the West Coast, they've always existed in places where humans are, but in the East Coast, they were traditionally confined to areas out in the Appalachians. But some behavioral changes have occurred and spread through the population, and now they're making great use of structures that we have here in the East, particularly as we switch to 5G and they put those platforms up. But also, there are other behavioral changes as well that allow them to exploit resources here. Same thing kind of happened with pileated woodpecker. Those birds were really uncommon when I first started birding some 40 years ago or so. Same thing with ospreys, boom, 5.88% increase. And of course, Canada geese are on the increase, which has a lot of ramifications too. And wild turkeys on the increase, about 8.75% per year. House finches, well, they started declining because after their initial expansion, that mycoplasm, the avian conjunctivitis set in and really knocked them back. And so they're now adjusting back down to what a biologist might call carrying capacity, which means a more realistic abundance. And the BBS traced that. They started up here in the Northeast in 1970 and 85, they were expanding. And then finally by 2005, the East and West Coast populations had met in the middle. And I mentioned boreal birds like rusty blackbird. Look at that, 6% decline per year. Nearly, that's what a decline of that number looks like. We went from having them to pretty much nothing now. They're very few and far between. So anyway, I promised I would stop. I'm going to do it now.
Thank you, David. When you showed the map, do you have routes in Hawaii?
No, we do not. I personally would like to do that, and I'm sure Mikey would too, because we would have to go out there and take a field trip to set it up. We had expanded into Puerto Rico, and we did have a trial period in Puerto Rico, which Bruce, Peter, John, myself, and Keith had worked with some of those data in the years following, and we had just determined that it was not really feasible in Puerto Rico, and I expect Hawaii would be much the same. It does not have the road infrastructure that it would need to do the survey.
Well, a couple of people have dropped off, but we'll feel free to raise your hand, ask a question, or put it in the chat. And just want to put in a plug that David will be leading a field trip on March 13th at Centennial Lake. And he's going to start off challenging already by putting it on daylight savings time. So you have to make sure your clock is set. But he shares some informative information, such as the scales on the fish, American crow, not on the fish crow, and the red in the tail of the cedar waxwing from eating the berries.
Yes, David, what is the driving factor in the steep decline in rusty blackbirds? Is it habitat loss or something else going on?
Yeah, that's a great question, Gail. Yeah, so some of the factors are not fully understood. The boreal avifauna in general is declining, and folks are not entirely sure what that is. Some of it is the aerial insectivore community up there, but there are a number of other factors as well. And unfortunately, there's been no really clear smoking gun. And so rusty blackbird is certainly subject to that. It lives in boreal bogs. And then when it comes down here during the wintertime, it suffered greatly when blackbird populations were being controlled to reduce the take of agricultural residue and that kind of thing. And also it is very particular for a blackbird in its wintering habitat. It is a specialist of flipping over leaves in very wet areas, usually on the side of vernal pools, and picking out the macroinvertebrates that are underneath of those leaves. And it also is believed to not perform very well in its wintering quarters unless it has minimum flock sizes. And so there's some interesting behavioral work that was done on that, and lots of cool stuff that was done by Russ Greenberg and a number of other folks who've looked at that in the past. But generally speaking, it's really suffered on multiple fronts. And one of those is just the loss of wetlands that had occurred. We have a lot of wetlands now that are really conducive to waterfowl that we've reestablished, Ducks Unlimited ponds and that kind of thing. But unfortunately, they're not equivalent in the minds of rusty blackbirds, which like forested wetland habitats.
Jay Shepard has his hand up.
Literally and figuratively. or
Yeah, both.
Dave, in the first 10 or 20 years of the survey, linear regressions were used for the trend lines, and I can understand that. But we've got 50 years of data now, or thereabouts, or more. Seems to me linear is no longer a valid treatment of the data. I mean, you showed the test-sided warbler, the rusty blackbird. All of them have declined, and then they leveled off the last decade or two. I mean, it may be a very low level, might be a high level, but the point is they're not a straight line, constant, increase or decrease. They are changing variably over time.
What you're seeing right there is those actual counts, that model adjusted annual indices that come right out of the BBS. So that is exactly what those populations are showing. So those are not products, like that trend line is basically just a line that's snapped over those points. So those are actual point data. And so the analysis that Jay is talking about, just for those of you to understand. So when you analyze these data, you have to control for a number of factors. So you have to use mathematical models to control for the fact, for instance, that there are differences between observers. So Mikey and I, for instance, might go and sample a route. I will sample it for the first 10 years. Mikey will sample it for the next 10 years. When I sample it, I may find 4 robins per year for 10 years. And Mikey will find 6 robins per year for 4 years, or for the next 10 years rather. And so between us, it appears that there's a population increase, but in fact, there really wasn't. And so you control for that by using mathematical models. So in the early days, those mathematical models that were used to do this, they were linear regression, which I don't want to overwhelm you here, but basically the idea is they're called linear regression because they use these mathematical functions. Mary Lou will know what I'm saying here. These mathematical functions that basically you would use in geometry to sort of determine a line. And then we progressed out of that about maybe 30 years ago, and we began moving towards more complicated low S smoothing models. And then eventually we moved to what we use now, which is Bayesian inference, which is very different than traditional statistics. And we use models that are very different than our log linear models from the past. We use these hierarchical models that take advantage of all the nested information that's in there to draw inference through those things. And what they're doing is they're correcting the data to account for these unusual phenomena. But the actual ups and downs, like you saw in that Carolina wren, they are up and down in that Carolina wren because that population has actually gone up and down, and that's the exact measurement.
I totally appreciate all that, David. What I'm saying is you are saying 4.6% either increase or decrease as a linear rate of what the population is changing. What I'm saying is that it may be over time 5 or 10% increase, and then a leveling off, and maybe a decrease like the house finch.
Yeah, and what you're essentially saying is that you have a trend between 1966 and 67, and then another one between 67 and 68, and another one between 68 and 69, and another one between 69 and that's what makes the up and down, is that trend. But if you come up with one trend that summarizes across all 50 some years, it's just going to be one number that indicates one direction of a trend. So it is just an average.
A trend line is a line analyzing all the data, and you are using a linear regression of function to get a straight line, to get a certain percentage change over that period of time. And that cannot be true in nature. Populations may be leveling off at a very low or very high level, and then once they're at that, the trend no longer applies once they have leveled off.
Yeah, so this is just one of the challenges, of course, with trying to summarize these phenomena. So, for me, when people are using those trend numbers like negative, 2% per year, folks often say, well, can you give me exactly what that would be over the whole time period? And, my answer to that is no, because it's not meant to be used in that way. It is one summary value. And the only reason we really provide that is because folks like in Fish and Wildlife Service say, I need one number I can put into a document here to say what has happened over that time period. So it's not really a scientist saying that, hey, this is something that describes the entire world. It's really saying that the world is very interesting, as you saw in the loggerhead shrike. It's a very dynamic place with lots of trends, and it depends on what scale of geography you take into consideration and what time scale you take into consideration too. So if you truncate, for instance, that trend interval down to just 5 years or 10 years, the trend that you get from a linear model will of course change. It's just a summary, and unfortunately, there are really not many other good tools there. But if you have suggestions, I mean, that would certainly be a great conversation to have, and John Sauer would be very willing to hear that. Of course, he has spent his entire career trying to figure out what would be great statistics to use to summarize these things. But your point is
He's
very well
retired
taken.
now, although I talk to him once in a while, but he's retired. So
He's
not
still
much.
working. John Sauer is very much still on the
What?
payroll. He's talking about retiring, but he's not.
I heard he
declared it.
retired. Oh, okay.
No, he's still very much on the payroll, and Bill Link is thinking about retiring, who's the mathematician, behind a lot of what he does. I'm sorry, folks. One thing that I have to say here is that I love Jay's discussion. And so for some of us, probably we would like to talk about maybe just very beginning birder things. And for other of us, we'd like to talk about advanced things. And I think you all are wonderful for just allowing us to talk about each of those things at each different level, because I think they're all really very valuable conversations to have. So I really appreciate what you mentioned there, Jay.
Well, thank you very much, David. It is 9:13. We're a little bit past our time. I think Gail might have another question.
No, I'm just going to say goodbye. I'll see you in Panama. See you in Panama. And that's where you need to have a route. On the Pipeline Road. You'll have a wonderful time, but you might not get 50 miles.
Oh my goodness. I did a lot of my graduate work in the tropics, and especially on Pipeline Road. So I know it very fondly. I wish I could go with you. Please take me in your suitcase. Best of luck to you, Gail. Thank you so much.
All right, thank you very much, David. It's a wonderful presentation. I've seen it another time, and I think this one was even a little bit different.
Thank you all. Have a wonderful night, and
Yeah.
thank you for inviting me.
You too.
Thank
Thank
you.
you. Good night.